Okay, so I'd like to welcome everybody to the first class in the new Kepler New Astronomy class series and work through. And just to give people a sense of what we expect for the class series, based on what we put together in terms of a proposal for a rate of working through the book, the amount of material we're going to work on in the book, probably looking at about a 3 to 4 month class series, which will be taught by various members of the basement. It's going to involve work by you guys in your locals each week for several hours to read parts of the book, work on parts of the New Astronomy websites, read some supplementary material, complete homework assignments, and so forth. So it should be pretty fun. In terms of supplies, I think everybody got the supply list. If you didn't, it's going to be linked in the video description. But the number one thing I would recommend is that everybody get a notebook and hold on to the notebook and keep it through the entire series, because it's going to be something you want to refer back to, and it's going to be something that you're going to want to keep so that you can teach from it. So I'm going to begin tonight with an introductory class, not so much on the New Astronomy per se, but more on Kepler, which we'll get to in a minute. This Sunday, July 6th, Jason is going to give a class over Hangouts, which will be an overview of the New Astronomy itself, sort of a quick summary of what people can expect from the book. So just to begin, what I'd like to do is give an overview tonight of the context of the New Astronomy. So I'd like to give people a sense of the context of Kepler's life, of the history of the period that he's living in, of the history of the period that he's thinking in, coming out of the Renaissance. And I'd like to give people what I hope will be a richer sense of the importance of the New Astronomy, which you're not going to get just by reading the book itself. You really have to know Kepler the man in terms of how he perceived what he was doing, how he was acting, and how he was thinking, and what his role was in civilization and for humanity. So I'm definitely not going to be able to give you a full sense of that tonight, but hopefully at least a taste. I just want to say I think it is urgent. It is urgent that we do this. It is urgent that we commit to mastering Kepler's mind and Kepler's thinking, because humanity is in such a profound crisis today. Not only a crisis of having lived with the domination of oligarchy for thousands of years, now coming to a point where we're facing thermonuclear extinction, but particularly now because with the domination of oligarchy, mankind has reached one of the most dark and profound crises in thinking that he's ever faced, where we've reached, because of what LaRouche always points, or has been pointing to recently, with the attack on science that was imposed in 1900, around the period of 1900, with the reimposition of the doctrine of sense perception, mathematics, mathematical description as a substitute for science. We've now reached the point where we have very few scientific geniuses, but we have 7 billion and growing people on the planet that we're going to have to ensure the survival of. We're going to have to confront some major scientific challenges in the coming decades if we expect to be able to carry civilization into the future, which means we have to remaster the method that Kepler carried forward from the Renaissance. Now, in terms of what that fight is, I mentioned the period around 1900 and the imposition of sense perception over thought. The idea that sense perception is all you can really know. Now, this was promoted by Bertrand Russell and other evils in the early 20th century. It dominates now, but it's not new. This idea, this fight, is as old as the oligarchy. It goes back to Zeus and Prometheus. It goes back to Aristotle, the tool of the oligarchy, who was deployed to crush the ideas of Plato. So this is what Cusa and his collaborators were fighting as they brought forward the Renaissance. And I just wanted to read a very short quote from Kepler's first published work, the Mysterium Cosmographicum, which I think beautifully gives you a very beautiful taste of his thinking. He says, "God, like one of our own architects, approached the task of constructing the universe with order and pattern, as if it were not art which imitated nature, but God himself had looked to the mode of building of man who was to be. So you think about how Kepler thought about humanity and humanity's relationship to his creator. It's not one of as Zeus thought, where man was this pestilence on the planet. It's not what Aristotle thought or said that he thought, that all that man could do was just take in what his senses gave him. But Kepler had the idea, as did Cusa, that man was designed in such a way that he would not only be able to understand how the Creator created the universe, he would also find it beautiful. He would find it within his power to recreate. So we're going to come back to this in a little bit. What I'd first like to do is go through and give people a little bit of a sense of Kepler's life, at least up until the time of his writing of the New Astronomy. So Kepler was born in 1571 in an area of Germany, which is in what's currently southwest Germany. People can see on the screen here where that little red dot is. He was born in a little tiny town called Wilderstadt, which is about 15 minutes west of Stuttgart. And he's born in 1571, which is about 50 years after Martin Luther officially launches the Reformation. And so he's born into a time when Germany's not a nation, it's a collection of duchies and other fiefdoms within the Holy Roman Empire. And you have had decades upon decades of devastating religious warfare, where most of the population were of the peasant class. You had some middle class, you had some noblemen. Kepler's family was from the middle class. Now, just a little bit about the area of Germany where he's from. Württemberg it became a duchy in 1495. It was ruled over by the first Duke of Württemberg, Eberhard I, or Eberhard the Bearded. And I think this person's worth looking a little bit more into. I did a little bit of research into him, and it turns out he traveled, before he became a duke, while he was still a count, Eberhard, along with a collaborator of his, Johannes Kepler, traveled from Germany and spent quite a bit of time in Italy, during the Renaissance, mind you, traveling from Rome to different parts of Italy, especially studying the educational system. Now, Clarus, his collaborator, spent time in Rome, met with Pope Pius II, who was a collaborator of Nicholas of Cusa. This is Piccolomini. And they came back from Italy to Württemberg and promptly set up the university at Tübingen in 1477. Now, Clarus becomes the first rector of the university, the first head of the university. So the little bit I know about it points in a very interesting direction in terms of a conscious attempt to bring the breakthroughs of the Renaissance, to bring humanism from Italy into Germany. This is the environment that Kepler is educated in. This is the region that he's educated in. Now, another thing about this time period is that it was riddled with religious conflict. There was, in 1630, there was something called the Confession of Augsburg, where all of the noblemen were forced to declare to the Holy Roman Emperor what their creed was, Lutheran or Catholic. And you had a collection of noblemen, including the one who ruled at the time Kepler's area, confessed to be Lutherans. This was known as the Confession of Augsburg. You had 2.5 more decades of devastating war with the Holy Roman Emperor trying to suppress the Reformation. In 1555, 16 years before Kepler was born, you had something called the Peace of Augsburg, which was somewhat of a compromise, where the emperor made a deal with the princes that you would allow religious toleration within the Holy Roman Empire. So in other words, each duke was allowed to choose whether he were Lutheran or Catholic. And all of the residents of his dukedom had to be whatever the duke was. So if the duke chose Catholic, you were going to be Catholic. If you didn't want to be Catholic, you were allowed to move. which sounds a little bit barbaric, but it was actually a certain advancement, because in the past you would have been killed. So you had what turns out to be a sort of temporary condition, the Peace of Augsburg, which Kepler did benefit from for a time. Now, there's a lot that could be said about the religious conflict, not just of Germany, but also as it involved Kepler personally. We don't really have enough time to get into it tonight, but it is worth saying that it really dominated and played a huge role in Kepler's life. He was, I mean, you had the 30 Years' War start in 1618, about 12 years before Kepler died. Kepler also was personally excommunicated from his church because of his beliefs about the his beliefs about the communion. Thank you. About the communion, which conflicted with the Lutheran orthodoxy. Okay, now in terms of Kepler's education, as a boy, he was chosen and sponsored to study at the little Latin school, the local Latin school, which was run by the Lutheran community and the community there, which was just a few miles from his town. It was in a town called Leonberg. And so he was put into this little Latin school, and he was put on a track to study theology. So at the Latin school, he would have studied Latin, and he would have gotten a basic education in mathematics and so forth. He then moved on from the Latin school to the seminary, which was another couple of miles away, where he was studying to prepare to go to the university at Tübingen to be a priest. And at the seminary, Kepler learned Greek. It was reported that he made attempts at writing poetry, that he enjoyed riddles, and that he was a very good student. Now, from the seminary in 1589, he enters the university at Tübingen. And this is, I mean, compared to where he's from, this is the big city. This is a huge metropolis, comparatively. At the university, he ends up, well, there's a couple things to say about it. Number one, he would have read Cusa here. It's known that he read Cusa. It's known that Cusa's writings were passed around among the students there. He was involved in he was surrounded by a very rich musical culture and often made comments on it. If people have read his Harmony of the World, they know he talks a lot about Orlandus, and that's one composer that we know was performed often at Tübingen. He also developed a number of lifelong friendships and relationships at Tübingen, particularly with his professor of astronomy, Michael Mestlin. And Mestlin introduced Kepler to the Copernican system. And it's a very interesting and tricky thing, and I think it's very revealing. Mestlin introduces Kepler to the Copernican system, has long discussions with Kepler on the Copernican system as being a more truthful system of the world. Now, Mestlin, however, is not as brave as Kepler, because much, much later in life, even after Kepler is dead, Mestlin publishes books on astronomy which are not based on the Copernican system, but are based on earlier Earth-centric systems. Now, at the end of his studies at Tübingen in 1594, so Kepler is 23 years old, he finishes his studies. He had expected to go to become a priest, but he doesn't get the chance to do that. Instead, he's nominated and asked by the professors at Tübingen to go and fill a post as a professor of mathematics and astronomy at the seminary in Graz. And I can just show people where that is. So Kepler's from, where this red dot is, that's Val der Stadt. The blue dot below it is Tübingen. And then if we go farther east, where you have this yellow dot, if you can see it, this is Graz. So this is in Upper Austria. It's in current-day Austria. And Kepler is summoned there. At first, he doesn't really want to go. He wants to go be a priest. So he has some resistance, but he finally decides that, yes, he'll go. So at 23 years old, he moves to Graz and begins teaching mathematics. He also taught, I think it was the report is, his biographer reports that his classes actually weren't very full. he never got very many students, and anyway, but so they allowed him to teach some other courses. I think it was on rhetoric or something, I forget what. Anyway, but later in his life, Kepler says that it was really the guiding hand of God that diverted his path from religion into astronomy. And so in his position as the professor of astronomy at the seminary, he also gets the job automatically of being the district mathematician for Graz, which is an interesting position because it means he has to write astrological calendars. And he's mainly writing astrological calendars for the local noblemen and, you know, giving them horoscopes of when they can expect to go to war, when you're going to have a, you know, natural disaster and the crops are going to be wiped out, when is going to be a good day to do this. There's also a lot that could be said on Kepler's activities in astrology, which we don't really have time to get into tonight, but needless to say, he was not a kook and mystic. He actually had some really interesting ideas about the influence of the stars and so forth on activities on the Earth. It is through this activity in calendar making he becomes famous because he's pretty good at it, and he ends up successfully predicting certain significant events in the region. He also makes friends with a Catholic nobleman, Herwart von Hohenberg or something like that, who ends up providing him through his life with a lot of books that he asks for and just generally giving him a lot of help. Now in Graz, he ends up meeting and marrying his wife and starting a family. He also is much more plagued with the religious tension that ends up becoming a much larger issue later in his life. Graz is much more of a zone of conflict, and as we'll see, that comes up significantly later. Now, really the significant event in his intellectual life that occurs while he's in Graz is that he ends up making the discovery which leads to the publication of his Mysterium Cosmographicum, the mystery of the universe. And in it, he reports his discovery of the reason for the number of the planets, why there are 6 planets, and also the reason that those planets lie at the distances from the sun that they do and not otherwise. And I'll just quickly show this picture is a drawing of his hometown Balderstadt from a few decades after he was born.
His drawing or someone else's?
No, someone else's. Yeah. So this is the diagram of his idea of the creator's plan for the geometry of the solar system based on a nested series of platonic solids. Now, there are a few significant things that I want to say that are relevant to us tonight about the Mysterium Cosmographicum. One of them is that in the Mysterium, this is early, he's 26 or something, 25, 26 years old. He's already raising the idea that not just the distances have a cause for their ordering, but that the motions of the planets or some feature of the planets are somehow linked to harmonic motions. And he has a whole chapter in there where he's talking about the different ratios of the different harmonic ratios that we later see him fully develop in the harmony of the world. That's very significant. Also in the Mysterium, he's raising the question of what is the relationship between the distance of a planet from the sun and its speed. And this is the issue that gets solved much, much later on in his life. It's not until 1618 that he finally solves that question. And then the third thing to say tonight about what's significant about this work is that already he's publishing an early hypothesis that the sun is the mover of the planets. He says there must be an anima motrix, or a moving soul, in the sun. So this is an extremely significant thing. He's encouraged by his old professor Mestlin to publish it. Mestlin helps him. Kepler publishes it. He sends copies out all around Germany. He sends it to his old professor. He sends one to Galileo. He sends one to Tycho Brahe, who we'll meet in a minute. And he sends it out asking for responses. He gets almost nothing back in terms of the letters that he was hoping for. He sends a letter to Galileo, who acknowledges its receipt and never sends him anything back on it. Okay, now 1597, the next year, the religious toleration in that state of Germany is overturned, and the new duke decides he wants to begin to repress the Reformation. So you have the beginning of the Counter-Reformation. So the Lutheran seminary at Graz is shut down, and all of the professors of the seminary are told they have to leave the state within 8 days or they'll be executed. Kepler manages to stay. And he manages to stay because not only is he a professor, but he's also the district mathematician. So he holds a post which is not religious, which is neutral. And so he gets shaky permission, but permission to stay in Graz. Now, he obviously doesn't have nearly as much to do. He has a lot more free time. So during this time, he begins making observations of the moon, and he begins making daily observations of the weather. And he continues this practice for about 3 decades. And this, again, comes into play in Book 4, in particular, of the Harmony of the World, where Kepler begins discussing the correlation of the weather and the activity of the Earth in relationship to the rest of the solar system. Now, another significant thing that he does at this time in Graz is that he puts out a hypothesis that the stars, that the sphere of stars that you see when you go out at night and look at the sky, that as opposed to what was thought by everybody up until that time, these stars were not infinitely far away from the Earth. He thinks that these stars actually have a fixed measurable distance from the Earth. And so he proposes that you could measure this by measuring the parallax of the North Star at different times, comparing the position of the North Star at particular times of the year. And by noticing a very, very slight difference, you could actually determine how far that star was away from the Earth. And he tries to do this. It doesn't work. His measurements aren't good enough. But this is actually accomplished in 1838 by a collaborator of Gauss, Bessel. And he does determine, using basically the same method, the first known distance of a star from the Earth.
What is your parallax mean again?
Parallax is the, one good way to demonstrate it is if you hold your finger out in front of you and then close one eye and then the other, it jumps, right?
Yeah.
So the observed position of your finger jumps because your point of view is moving.
Okay.
And so you can determine through simple geometry, you can determine how far that observed thing is from the observer.
So if there is a parallax, there's a difference, you can find out how.
Yeah.
When did Bessel do that?
When? 1838. Okay, so it's in 1600. Religious tensions have gotten much worse. Kepler knows that he needs to start looking for something else. And he finally manages to get a response from Tycho Brahe. Tycho Brahe is pretty much the premier astronomer and observer of Kepler's day. He's a Danish nobleman. He ends up having to flee Denmark and is given a home by the Holy Roman Emperor, Rudolf. So Rudolf adopts Tycho Brahe as the imperial mathematician. Tycho Brahe has the best not telescopes, but the best instruments of observation of anybody of his day. Tycho is basically spending his life making new observations of the stars and the planets. Up until this time, everybody is using either backyard observations like what Kepler tried to do with the moon, and not many people were doing that. People were basically using the data that had been available since Ptolemy, since the 2nd century AD. That was the data that scientists and astronomers were using. So Tycho was making his life's aim was to make a new table of observations of the planets. So Kepler knows that he needs to get access to Tycho Brahe's data and needs to become a collaborator with Brahe, if he's going to be able to verify some of his hypotheses in the Mysterium. So in 1600, he finally receives an invitation to come and visit. So he travels from Graz to Prague, and if we look on the map here, Graz is this yellow circle down here in the right-hand corner, bottom right. Prague is this green circle above it. It's about 4.5 hour drive from Graz. So it's quite a journey. And it was quite expensive. So it was a big deal. So Kepler travels to see Bra. And as soon as he gets there, he's assigned to start doing some work for him while he stays. And Kepler's hoping that while he's there, he'll get to just have free reign of Tycho's observations, but he doesn't. He's only given the observations that are particular to the problem he's working on. Now, interestingly, while he's there for this short visit, he ends up developing a new hypothesis of the motion of the moon. Apparently, Tycho's hypothesis for the motion of the moon was geometrically crazy. It just had tons and tons of extra epicycles where you have an orbit and then another orbit around it and then another orbit around that. Kepler proposed instead a system which actually had a physical hypothesis of the Earth moving the moon. And he said, in it, he said, there is a force in the Earth which causes the moon to move. So you already see where his mind is headed. Now, at the end of September, Kepler ends up moving his entire family out of Graz up to the area of Prague, and they actually move in with Tycho Brahe. It's a big castle. And when he arrives, he's assigned to work on the theory of Mars, along with one of Tycho's assistants who ends up leaving after a short time, Longomontanus. And so Kepler's given the very difficult task of working out the theory of Mars. And what that means to work out the theory of Mars is that he was, based on Tycho's new observations, he was supposed to determine the correct size of the eccentricity of the orbit of Mars. And if people don't know what that is, you will next week. And he was also assigned to determine the direction of the line of apsides of Mars. So if you connect the 2 points on Mars's orbit of its farthest distance from the sun and its closest, and you make that line, that's the line of apsides. So he was supposed to figure out what star did that point to in the sky and how eccentric was the orbit. Now, Kepler thought, he said, this will take me 8 days. Easy. It ends up taking him almost 9 years, 8 years basically. Now the reason it ends up taking him 8 years instead of 8 days is because he ends up overturning the entire science of astronomy up to that point. And he literally overthrows astronomy as a science of geometry and mathematics and modeling the appearances in the sky. And he refounds astronomy as a branch of physics. And that's what we're going to work through over the next months in the new astronomy. Actually work through blow by blow, not just his process of discovery, but his pedagogical idea of how you take somebody through coming to that discovery, hitting that wall, and coming to the idea that it's necessary to overthrow the current system, and then making that leap of discovery of what the true principles are. So what I'd like to do now is just give people a little bit of a taste of what astronomy was up to that point. And I'm not going to do it by showing you diagrams. We actually will get into that next week and the week after when we start looking at part 1 of the new astronomy. What I'm going to do is I just want to talk a little bit about the people who had dominated astronomy up until Kepler's time. The first, and really the main one, is Aristotle. Aristotle lived in the, 3rd century, 2nd century BC, and yet he dominated in astronomy up until 1609. So I just want to first, let me just say what was Aristotle's ideology, what was his system? His system was that the Earth was the center of the universe. And you know that because that's what you see. The Earth was composed of all of these changeable elements like water and earth, which are heavy, and air and water, which are light. And the details aren't that important, but so Earth is this changeable, heavy, weighty thing, which is at the center of the entire universe. The heavens were something completely different. The heavens had entirely different laws which governed them. They were made of ether. They were eternal. They were not created. They were perfect. They moved in, there could be nothing in the heavens except for circular motion, which was perfectly uniform and never ceased. The different motions of the different planets and the stars were caused because these stars and planets were embedded in these crystalline spheres, which were made of ether and which filled up space. It was a plenum filled with these crystal spheres. In a nutshell, that's the Aristotelian system. So let's just look at this. Oh, actually, no, I don't want to do that one yet. Okay, so that's the Aristotelian system. Now, in 150 AD, as in the middle of the Roman Empire, you have Ptolemy. Now, Ptolemy again dominated up until Kepler's time, and I just want to read this quote from Ptolemy's work called the Almagest, or what's the other word?
Syntaxis.
The Syntaxis. So as you'll see in the two quotes we're going to read, Ptolemy was not just a follower, but a defender of Aristotle. He apologized for Aristotle. So this is from the Almagest. He says, so what he's talking about here is how you know the Earth is at the center of everything. And so it also seems to me superfluous to look for the causes of the motion to the center, why everything falls to the center of the Earth, when it is once for all clear from the very appearances that the Earth is in the middle of the world, and all weights move towards it. And the easiest and only way to understand this is to see that once the Earth has been proved spherical, considered as a whole, and in the middle of the universe, as we have said, then the tendencies and movements of heavy bodies, I mean here their proper movements, are everywhere and always at right angles to the tangent plane drawn through the falling body's point of contact with the Earth's surface. So how do we know that the Earth is at the center of the universe? Because everything goes to the center of the universe, and everything goes to the center of the Earth, and because that's how things appear. Now here's his reason why it cannot possibly be the case that the Earth moves. It must instead be the case that everything else moves. He says, and if the Earth had some one common movement, the same as that of other weights, it would clearly leave them all behind because of its much greater magnitude. And all the animals and other weights would be left hanging in the air. And the Earth would very quickly fall out of the heavens. Merely to conceive such things makes him appear ridiculous.
Or it makes him appear ridiculous to conceive of such things.
So that's Ptolemy. As you might have guessed, Ptolemy's system is an Earth-centered system. Now I'd like to look quickly at Copernicus. Now Copernicus dies in 1543, and on the revolutions of the heavenly bodies is published in 1543, right after he dies, so that he's not around to deal with it. So anyway, so Copernicus is a heliocentric system in the sense that he reverses the roles of the Earth and the Sun. So rather than the Earth being at the center and being the center of observation of all the motions of the heavenly bodies, now the Sun is near the center of the system and the Earth moves. Now, this obviously was a revolution, and Kepler was very provoked by Copernicus's work, as were other important people. But as you'll see from the next quote, Copernicus didn't play the same role as Kepler. Copernicus actually was not interested in redefining astronomy. He was still interested, as Aristotle and as Ptolemy were, in being able to account for the appearances in the heavens.
He wanted the book
Yeah. So his interest was into being able to account for appearances and calculate the system of the heavens. He had no interest in physics. So Copernicus said in 1543, "We must, however, confess that these movements are circular, or are composed of many circular movements, in that they maintain these irregularities, the irregularities of motion, in accordance with constant law and with fixed periodic returns. And that could not take place if they were not circular. For it is only the circle which can bring back what is past and over with. And in this way, for example, the sun, by a movement composed of circular movements, brings back to us the inequality of days and nights and the 4 seasons of the year. Many movements are recognized in that movement, since it is impossible that a simple heavenly body should be moved irregularly by a single sphere. For that would have to take place either on account of the inconstancy of the motor virtue, whether by reason of an extrinsic cause or its intrinsic nature, or on account of the inequality between it and the moved body. But since the mind shudders at either of these suppositions, and since it is quite unfitting to suppose that such a state of affairs exists among things which are established in the best system, as Aristotle said, it is agreed that their regular movements appear to us as irregular, whether on account of their circles having different poles, or even because the earth is not at the center of the circles in which they revolve." So again, Copernicus is, and Kepler points this out, Copernicus is still defending Ptolemy and defending Aristotle. Now I want to give a contrary example. So Copernicus is 1453. Now, almost contemporary with that, although not quite, a little bit earlier, is Cusa. And Cusa's writing of Didacta Ignorantia. And in book 2 of Didacta, Cusa says this. Oh, actually, sorry, this is not the one I wanted to read, although that's a really good one, and I'll send it out. Cusa says this. He says, "No 2 things in the universe can be altogether equal." And then he goes on and he says, "However, it is not the case that in any genus, even the genus of motion, we come to an unqualifiedly maximum and minimum. Hence, if we consider the various movements of the spheres, we will see that it is not possible for the world machine to have as a fixed and immovable center either our perceptible earth, or air, or fire, or any other thing. For with regard to motion, we do not come to an unqualifiedly minimum, that is, to a fixed center. For the unqualifiedly minimum must coincide with the unqualifiedly maximum. Therefore, the center of the world coincides with the circumference. Hence, the world does not have a fixed circumference. And that should make you think about Cusa's hypothesis about the stars not having an infinite distance. For if it had a fixed center, the world would also have a fixed circumference, and hence it would have its own beginning and end in itself, and it would be bounded in relation to something else, and beyond the world there would be both something else and space. But all these consequences are false. Therefore, since it is not possible for the world to be enclosed between a physical center and a physical circumference, the world, of which God is the center and the circumference, is not understood. And although the world is not infinite, it cannot be conceived as finite, because it lacks boundaries within which it is enclosed. Therefore, the earth, which cannot be the center, cannot be devoid of motion. Indeed, it is even necessary that the earth be moved in such a way that it could be moved infinitely less. Therefore, just as the earth is not the center of the world, so the fixed stars are not its circumference. Although, when we compare the earth with the sky, the former seems to be nearer to the center, and the latter nearer to the circumference. Therefore, the earth is not the center either of the eighth sphere, he's referring to Aristotle's system, or of any sphere. Now, for time, I'm not going to read the next one, but in the following chapter, chapter 12, he also says, not only does he say that the earth cannot be the center and that there can be no center, he says that the earth must tend towards sphericity and that the earth's orbit must tend toward a circle but will never be a perfect circle, or that orbits, motions, will tend toward circularity but will never be perfect circles. So this was the product of the Renaissance, which was really waiting for Kepler to realize it. Now, on to the third figure in astronomy who we talked about before, Tycho Brahe. Tycho's system was, again, an Earth-centered system. So the Earth is at the center, the Sun moves around the Earth, and all the planets move around the Sun. Now, Tycho Brahe ends, so Kepler lives with him, is working under him. Tycho ends up dying in about 1 year after Kepler moves in October of 1601. Kepler is asked to replace him as the imperial mathematician. So Kepler is now the imperial mathematician for the Holy Roman Empire. And this leads to a couple things. He's imperial mathematician. Hypothetically, he inherits all of Tycho's instruments and all of Tycho's observations. Yet, this doesn't end up exactly being the case. There are huge fights with Tycho's family, particularly Tycho's son-in-law, who is a big thorn in Kepler's side with pretty much everything. He doesn't want to give Kepler access to the data. He doesn't want to let Kepler publish anything which uses Tycho's data. So Kepler's in a bit of a bind. So this is 1601. He ends up spending the next 7 years working out the orbit of Mars, and of all planets, not just the orbit of Mars, the orbit of the Earth and all planets as well. In 1609, he's finally able to publish his discovery, the New Astronomy. Now, this publication of the New Astronomy meets with almost universal resistance, not just from people who disliked Kepler, and there were already many of those because of his Mysterium Cosmographicum, but it also meets with strong resistance from his friends. For example, his friend and correspondent, David Fabricius, writes to Kepler and basically says, look, I don't think you should be promoting this. I don't think physics has anything to do with astronomy. I think you'd better back off of this. And after a couple more exchanges of letters, Kepler ends up never speaking to him for the rest of his life.
We can relate to that.
So, but you imagine why? I mean, what's Kepler doing? He's not only is he tearing down the edifice of astronomy up to that point, as if this is some academic issue, but Kepler is going face to face with the oligarchy itself. He's tearing down the Aristotelian tyranny, which had dominated mankind for millennia, and imposed the idea that knowledge can only come to man via his senses. And what Kepler really does is delivers a devastating proof that no, discoveries do not come from the senses. Actually, anybody who tries to create a system which merely explains appearances will end up creating something which is false. And what Kepler puts forward is a superior method, which is the method of Cusa, which is that discoveries do not come from the senses. They come from being able to overturn and explain the paradoxes of sense perception via a discovery and a leap of the mind, which means that the mind is actually drawing from itself the truth, a measurement of truth, conceptions of physical truths, universal truths. And this is flying right in the face of the system of oligarchy. So what I'd like to do now is just go to book 4 and read a few things from book 4 of Kepler's Harmony of the World, which is, I think, one of, not the only, but one of the best expositions from Kepler himself of where he sees himself in this fight, where he puts himself in the fight of the Renaissance, in the fight of Plato, and in the fight against Aristotle and against the system of oligarchy. And so the way he does this is actually really interesting. If people have, anybody who's read all of book 4 knows that a good majority of it is taking up the issue of the aspects or the influence of astrological positions of stars on occurrences on Earth, on the personality of human beings. And it is a really interesting thing to read. The first 3 chapters are an explicit discussion of the nature of the human mind, and particularly the nature of the human mind's relationship to the senses. And people who have read Cusa, it should also resonate that this is very much continuing the ideas of Cusa, that man's mind is an image of the mind of the Creator. And that's how it is that it's able to draw, that the mind is able to draw discoveries from itself. So I'd like to read a few quotes, and then we can just discuss them and anything else you guys want to discuss. So he does this in a really interesting way. In chapter 1 of book 4, he begins this assault on the Aristotelian ideology by taking up the issue of harmonies and how it is that a harmony is perceived by the mind, why it's harmonic. So what are the essence of harmonies and how are they perceived? What's going on? So I'm just going to read a small passage from the very end of that chapter where he gives a summary. He says, so just to preface it a little bit, he's kind of gone through this very detailed discussion saying, okay, well, in order for there to be a sensible harmony, for example, a harmony between 2 musical tones, a harmony of sound, you need 2 sounds. You need a soul or something which is going to compare the 2 sounds. You need the reception of those sounds into the soul so that it can do the comparing. But he says you also need something that the soul is going to compare that relationship to. So, in other words, you can perceive something, the mind can take it in, the mind can create an idea of its relationship, which is a single thing. But unless the mind has something to compare that relationship to, why would or would it not be harmonic? What's determining what makes that beautiful and harmonic to the human mind? So here's his summary. He says, therefore, to conclude this section, we shall gather the chief points into a package. For the sensible harmonies have this in common with the archetypal ones, that they demand terms, 2 different things, and the comparison of them, an activity of the soul itself. The essence of both consists in this comparison. But the terms of the sensible harmonies are sensible, and must be present outside the soul. The terms of the archetypal harmonies are present within the soul itself beforehand. Therefore, the sensible harmonies need, in addition, to be received by means of an emanation which they have emitted. And it is by the senses, the servants of the soul, that they are received. Another comparison is also needed, of the individual sensible terms with the individual archetypal ones. I mean, with the circle and a knowable part of it. But the archetypal harmony has neither need, as its terms are present in the soul beforehand and inborn in it, and in fact are the soul itself, and they are not an image of their true pattern, but are in a sense their own pattern. Thus, only a simple comparison, which the soul sets up of its own parts with each other, so to speak, completes the whole essence of the archetypal harmony. Finally, the soul itself, engaged in this activity, is the harmony with which we are concerned, just as, without reference to this activity, the circle and its part are. That is to say, they are the terms of the harmony. And in the end, harmony is wholly spiritualized and so deified. So this is really going against not only the Aristotelian idea of sense perception, but also the modern idea of sense perception. So perception is not a passive thing. You're not a passive resonator that's just impinged upon by the outside world, and that forms you. Instead, he says on even the lower level, when you're talking about like sensible things that you see or hear, already that requires the activity of the mind. So the senses bring them into you, but the mind has to actually create an idea of what it is. But then he says that there are certain ideas which are inborn, in a sense, which are passed down to man by virtue of the fact that his mind is an image of the Creator's mind. So this is a completely different idea of how man forms ideas and concepts of the outside world. Now here's another one from a little bit earlier, which gets at the same point. Kepler says, "You may ask how knowledge of a thing can be possessed when the mind has never learnt it, and perhaps cannot learn it if it is deprived of sensation of external things." To this, Proclus replies above in words which are commonplace in his philosophy. We today, if I am not mistaken, quite correctly use the term instinct. So this is interesting. How does the mind come to know things which it doesn't just gather from the world around it? Instinct. Indeed, to the human mind and to other minds, quantity is known by instinct, even if for this purpose it is deprived of all sensation. Of itself, it understands a straight line. Of itself, an equal distance from a given point. Of itself, it forms for itself from these an image of the circle. If so, it can much more readily find the construction by means of that. So by means of these mental conceptions of a point, of a distance from a point, and of the creation of a circle, which is occurring in the mind. He says, from that, it can much more readily find the construction, and so perform the function of the eye in seeing a diagram, if there is nevertheless the need for one. Certainly, the mind itself, if it never had the use of an eye at all, would demand an eye for itself, for the comprehension of things which are placed outside it, and would lay down the laws for its structure, which were drawn from itself, if, in fact, it were pure and sound, and without hindrance. That is, if it were only what it is. For the recognition of quantities, which is innate in the mind, dictates what the nature of the eye must be. And therefore, the eye has been made as it is because the mind is as it is, and not the other way around. And why waste words? Geometry, which before the origin of things was co-eternal with the divine mind and is God himself. For what could there be in God which would not be God himself? Supplied God patterns for the creation of the world, and passed over to man along with the image of God, and was not, in fact, taken in through the eyes. Therefore, since quantities possess constructibility not by virtue of the figures passing before the eyes, but in virtue of being clear to the eyes of the mind, in virtue not so much of having been abstracted from sensible things, but of never having been associated with them. So that's his idea. Now, anybody who's read Aristotle knows that he's completely defying Aristotle. There's also, I'm not going to read it now because I'd like to get a chance to have some discussion, but there's also a very good passage from Kepler's quotation of Proclus, where Proclus is again taking up a challenge of the Aristotelian idea that man's mind is just a blank slate, where Aristotle says in his book De Anima, on the soul, that the soul has no ideas of itself. The soul takes the form of whatever it's contemplating outside of itself, and takes in forms, and from them generates ideas, such as an idea of a circle. So Proclus challenges this and says, well, if that's true, if man forms an idea of a circle because he sees a lot of different circles in the sensible world, how does he actually measure the validity of his conception of the circle? If he's just seen a bunch of circle-like things and has formed an approximation based on generalizing this, how does he actually know what's valid, if that is a valid circle, or if he sees another one after that, if that one's more valid than the conception he formed? And Proclus says, no, this is ridiculous. There's something innate in the mind by which the mind knows truth, and it's not taken in through the senses. And it's actually on this basis, on Aristotle's assertion that the human mind is just a blank slate, which is written on by perception. Kepler says that because of that idea, Aristotle should be thrown out of the Christian religion. So, yeah, I think I'll just stop there. But again, I'll just reiterate that I'm very excited about the class series we have coming up, and I think we should all really commit to mastering Kepler's mind. It's more important than ever today, and this really is the issue in science, in all of human thought. And we saw this in the 1980s when LaRouche had these Fusion Energy Foundation meetings, and he brought up the work of Kepler, and you saw the complete freak out in the room, which is a sign not of these people being bad people. Most of them were good people, but it's a sign of the brainwashing in the educational system, which sticks to the idea that you have to have a mathematical proof and demonstration of a principle. And that's just not true. So anyway, I think I'll leave it there and take questions, discussion, anything you guys want to bring up. Also from the room.
Megan, do you know when Aristotle really started to be saturated into the Christian religion, or was it just kind of...
I don't know. Mm-mm.
Well, Dennis had a part in that.
Well, I know Daniel had gone through some of that. They were mass translating Aristotle.
Yeah, there was a whole sect that was created in the Christian religion that was based on Aristotle. It was promoted in the eastern part of the Roman Empire, Byzantium, and anyway, later on they were used under the Ottoman Empire.
Okay.
The one that Lynn used to, the hesychasts.
The what?
Hesychasts. Lynn used to talk about them when we were translating Vernadsky.
Okay.
Because that ended up in the Orthodox Church as a section of it. It was based on Aristotle.
People can also speak up if they have thoughts about book 4. I know a lot of people did get a chance to read it. Or maybe you're excited to know.
I was wondering, can you hear me?
Yeah.
Yeah, I was just wondering, I didn't really put too much, thought into it. I could have put in more, but I was thinking, because he specifically refers to paradigms or archetypes of the harmonies, that they're inherent in the soul and they're not outside the soul. They don't exist outside the soul. But obviously he's referring to the process of, like the kind of process you'd go through in book 3, which is, comparing the ratios of the, comparing the proportions. But that's the process he's referring to. So I was just wondering, because I still don't quite know like what he means. Like, what's an archetype of a harmony? Is he talking about just like the ratio itself, like 1/2 or something like that? Like that's the archetype of the like all the specific like sensible manifestations of the harmonies, or like what? Yeah, I was just wondering what other people thought. So.
Yeah, he's talking about what he set up with books 1 and 2, which is what he's basically doing is he's taking the idea of harmonics, which had been passed down to us from the work of the Greeks and others, which was based on number. So the causes for why certain sounds are beautiful and musical, and why our musical scale is built as it is, those were explained by the properties of number. And Kepler says, no, numbers aren't physical. Number in and of itself and the properties of number, in other words, a language of mathematics, it isn't a physical power of construction. So what Kepler does and sets up in book 1, his book on geometry, is he establishes what he says is his own discovery of the fact that the causes for the musical system are not the numbers, but the geometrical shapes, such as the constructible geometrical figures, which are divisions of a circle. So figures like the triangle, the square, the hexagon, the pentagon, the octagon, and then all of the figures that you could construct from them. So now, he shows that the proportions which are associated with these constructible figures. So for example, if we had a circle and we divided the circumference of that circle into 4 parts, we've inscribed a square inside of that circle. The proportions that are generated from that construction, such as 1:4, 2:4, and 3:4, those proportions are also all proportions of consonant musical harmonies of a vibrating string. So, but it's important that Kepler's doing this because he's basing the idea of harmony in the idea of man's power to create, man's power to generate in the physical universe, based on this the geometric constructions that he's capable of creating and knowing. So that's what he means when he's referring back to these archetypal harmonies, are the ones that are actually based on these inherent geometric figures that man is able to know and generate. And he actually says that's why these things sound beautiful. That's why these proportions, such as 3:4, sound beautiful when they're realized in musical sounds, is because they represent a constructible proportion by man. So I don't know if hope that answers your question, but that's what he's referring to. But I just think it's significant because it's takes it out of the basis of Euclid in terms of just axioms, and it's really based on Kepler's own idea that man is a co-creator, and that God would not have created anything that wouldn't have fit man's own ability to create.
That's what I was going to ask you about, was what you think Kepler would say about the, well, you know, you brought up Aristotle and whether things come from the senses or if they're in the mind. We were reading the discourse, we finished the discourse on metaphysics just now, and Leibniz has a thing where he compares Plato's theory of reminiscences and then immediately afterwards talks about how Aristotle said that mind is a blank slate, things are simply written on it, and that nothing would get to it that didn't come from outside. He thought it was the other way around. I was wondering, you just brought up, you know, in De Barillo, Cusa talks about how one of the problems with, he says an advancement beyond Plato is to what extent man is a co-creator. In other words, to what extent do we create things as opposed to discovering things that are already in the mind? What do you think Kepler would say about that?
You know what? He actually, I don't know if I could find it now, but he actually brings that up directly, because he says something like you might say to me that man doesn't create these harmonic proportions, he just discovers them. Oh, I know where it is. He says here someone might object that the soul, in comparing, does not make the appropriate proportion, but discovers it. Therefore, it seems that the soul could be absent without the loss of the essence of harmony. I reply by inverting the question. To find the appropriate proportion in sensible things is to uncover and recognize and bring to light a similarity of that proportion in sensible things to some particular archetype of the truest harmony within the soul. Therefore, just as the Athenians found some virtue in Zeno and did not find the privileges of the Prytaneum in him, but conferred them on him, which Zeno could not achieve without the Athenians, so the soul finds order and proportion in the sounds and rays, although it does not find even that outside, but finds the terms inside as stated, but makes this proportion harmonic itself by comparison with the archetype. It could not be called harmonic, and would be allotted no power in moving spirits if the archetype did not exist. Is that clear what he's saying? It's a little bit confusing. So he's saying you might advance the argument to me that just by comparing two terms and finding that it's a harmonic proportion, the soul isn't making the harmony, it's just finding it. It's just discovering it. But he says, okay, so let me give you an example. And he gives this example of Zeno. The Prytaneum was a town hall where distinguished visitors were given the privilege of dining with the council. So you have to be distinguished to visit the Prytaneum. So he gives this example of Zeno. He said, the Athenians found virtue in Zeno. They discovered virtue in Zeno. But Zeno didn't possess these special, distinguished privileges in himself. He possessed virtue, which then you could say resonated with or corresponded to the Athenians' standard of virtue to be granted these privileges. So he's saying similarly, the mind in noticing a particular proportion between two sensible things, just by that's not harmonic. That proportion has to actually resonate with or recall something in the soul which is harmonic. And the soul can recognize that quality of harmony in that proportion which it's recognized. So that's what he would say about it.
Hey, Megan?
Yeah.
On that, I was going to ask, I was a little bit, I think maybe you touched on it a bit, but when it goes into the idea of sensible harmonies versus insensible harmonies, it seems like he was talking about a sensible harmony might be when you have a regular figure compared to a circle, and you have a certain proportion, like 3/4, and you can play it on a string. But then when he talks about insensible harmonies, he says it only occurs in the mind. We have no emanation acting on your sense apparatus, but that it's like two different ideas in the mind then compared, where the insensible harmony isn't in either thing. But I was wondering if you could give an example of it, or just tell me what he's getting at there.
You mean like what the insensible harmonies are?
Yeah, exactly.
Yeah, he is talking about what he keeps calling these archetypes or archetypal harmonies. So one way to start to understand what he means by it is that he brings up the fact that you have a harmony in the proportion of 1 to 2. And in music, we call this harmony an octave. In the aspects, the motion of the impact of the planets on the Earth, we call this the aspect of opposition. In geometry, this is the diameter of the circle. And so you have one harmonic proportion which will manifest itself in many sensible things, but it itself is above those sensible things. And the thing that I find really interesting is that Kepler is saying that these harmonic proportions actually have qualities, that you can kind of have a sense of the quality of a harmony which is above and outside of any of the particular sensible manifestations of it. And I mean, kind of the ultimate unsensible harmony is his idea of the harmonies of the planets, although they are sensible to the sun at times. But I would say, yeah, for him, his idea of the unified harmony of the planets is an unsensible harmony.
Question. This is chapter 1 of book 4, and this specific example stuck out, and it's when he's talking about the degrees of ambiguous passive experience. Here, talking about he describes water. And to me, this example stuck out. And how can you explain a little bit more of how this is passive, or is it intelligible, or how does it relate to the archetype of harmonies also?
Yeah, sure. Yeah, so people who maybe haven't read it in a little while, Kepler is talking about how sensation works and whether it's a passive thing or an active thing. And so he uses the example of water. And he spends a few pages on it. He goes through a whole list of instances in which water can be perceived. So it can be tasted, it can be smelled, it can be felt, it can be seen. And he goes through all these different examples that, I mean, I know the first few times I read it, though automatically I would say that if you are tasting water, you're looking at water, you're being passive. That water is impinging its image on your senses and you're being hit by it. But Kepler is going through this whole list of how actually in perceiving the mind is active. And so he gives the example of tasting water. He says when you swallow water, your tongue warms up the water. You swallow it, and so your tongue is lightly hitting the water to move it down your esophagus. When you see water, you have the rays of light which strike the water, come to your eye, and the eye, he says, he calls it the net-like coating. He's talking about the retina. The retina actually reacts to the emanation of water, the light, the reflection of the water. The retina reacts to it and generates an image for the mind, for the brain. And then similarly with hearing. And so he's just going through all these instances where you would at first say that you're just a passive receiver, but actually the mind is acting. Instead of you being acted on by the water, you're acting on the emanation of the water. And so that's kind of his first step to getting to the idea that like sense perception doesn't form you, but it's the other way around.
Yeah, I got a question about tempering. I didn't know if that's something that we can anticipate learning about in the new astronomy, or if that's something that is put off later in Harmonies of the World. We had a class where it was presented, and I didn't know if tempering is archetypal, the way that he talks about the harmonic constructions related to divisions of the circle, or if tempering has a greater variability. It was something I was wondering if we can anticipate learning over the next few months, or if we should just think of it as something to learn beyond this experience.
Yeah, he doesn't get to tempering in the new astronomy. There's plenty of adjustment and calculation, but not not tempering. The one thing I would say about it, in terms of whether he would consider the harmonic proportions an archetype, I don't think so. I don't know. But one thing I do know is that he makes all of the little adjustments to his harmonic ratios that he does in the Harmony of the World. When he's conceiving of the construction of the solar system, he makes these tiny little adjustments in making the intervals wider or narrower, and it's not because of anything he's heard. It's all from that same kind of mental process of how would God have constructed the universe. Oh, and this is actually a good time to bring up my Kuza quote. This is from Kuza's Didacta, and for me, this just described exactly what Kepler does in Book 5 of the Harmony of the World, where his axiom 1, his first and one of his only axioms that he's going to follow in his thought process is that God would have created the most beautiful solar system with the most variation. So Kuza says, who would not admire this artisan who, with regard to the spheres, the stars, and the regions of the stars, used such skill that there is, though without complete precision, both a harmony of all things and a diversity of all things. This artisan considered in advance the sizes, the placing, and the motion of the stars in the one world, and he ordained the distances of the stars in such a way that unless each region were as it is, it could neither exist nor exist in such a place and with such an order, nor could the universe exist. Moreover, he bestowed on all stars a differing brightness, influence, shape, color, and heat, and he established the interrelationship of parts so proportionally that in each thing the motion of the parts is oriented toward the whole.
Bear sent in a question.
Oh.
Or I can read. Bear said, on your introduction on how do we know it's harmonic, as per Kepler's idea, I can't help but think of Plato's Republic, Book 6, specifically the latter part before going to Book 7 discussing the cave. Book 6, where Plato discussed about the object and the senses that perceive it, and eventually goes to the human mind's unique character, if I may say so. It just seems Kepler is using the Platonic method, that is, Socratic.
Yep, I think that's absolutely right. And Kepler definitely saw himself as being a Platonist. Although, I mean, he saw himself absolutely as a Platonist, and he leans very much on people like Proclus, who are Neoplatonists. I also think he, as is hopefully clear and will become clear to people who haven't read him yet, he also is really picking up on the advancements of the Renaissance, which were added to the ideas of Plato. But yeah, I think that's absolutely right. He also references the Timaeus quite a bit. Yes, Jason?
Okay. Well, just on the discovering versus composing, I was thinking about how in the harmony, at the end when Kepler's putting together planets, it doesn't seem like it seems less like finding something that was already there than some other discoveries do, because he had to do a lot of work to put everything together, to temper it. I mean, he's really acting as a composer. Although in the end, it seems like he's also finding something that was, well, obviously sees himself as finding something that was already there in the planets or in God's intention for them. So I was wondering what you think Kepler might say about what the difference, are there any differences, or what's the difference in the quality of mind of a discoverer and a musical composer? Are they creating a song? Are they finding music that was somehow already there? What's...
I'm not sure. Although he definitely thought of polyphonic music as a discovery. He didn't just think of it as like a cool innovation in culture, like a new style. He actually thought of polyphonic music as a scientific advancement that man had to discover. Like that God wanted us to discover polyphony, it's lawful. And that it was only in the recent period, just really during his lifetime, that man had actually discovered the science of polyphony in music. In terms of the more profound aspect of musical composition, I don't know. I mean, Furfinger definitely would.
Hey, Megan?
Yep.
So I know you went over this before, this idea of, the harmonies coming from the proportions which are constructible out of a circle. But I'm still kind of trying to wrap my mind around it, because I was just thinking about what he was saying about the sensible harmonies and how, how the sensible harmonies are specific instances of the, the pure and secret harmonies. And you use those examples like visual magnitude of like 1 to 3, or audio, an audio proportion, which of a third or something in music. So there's all these different expressions of a harmony of 1/3. But then, and so it seems like that the harmony itself doesn't have, it doesn't have a specific form. But then, he goes on to say that these harmonies are the circle and the parts of the circle. So it's like it seems like he's giving form to something which he said didn't really have form. And so I'm not really seeing why he brings this circle division of the circle thing into and attributing that to these pure secret harmonies.
Mm-hmm. Yeah, well, I think it's because he doesn't so much mean the actual visible diagram of the circle, like the construction you might have created on your paper at the end, but he's using that to really stand for his idea of man's power to create, like man's power to wield a certain action which can generate an intended division of a circle. So I don't know if that clarifies it more. I think I think that's the best way he's able to use the language to actually represent that concept. It's because he really is talking about man's power to intentionally generate a certain order or structure, and you find it in these expressed, for him, in a very superior way in these geometric forms. There might be some more history to it too, just in terms of there probably is a richer history to it in terms of the science of the time and the science leading up to Kepler's time, in terms of how these geometric figures and constructions were perceived and were part of the scientific culture and the culture of knowledge. Yeah, so that's what I'd say. But then I also just think about kind of actually what you just brought up just a minute ago about how he ends up using these archetypal harmonies in his own mind, in the action of the creation and the generation of the solar system. So he really is all the time thinking of the action of creation. What can man create? What can man know? What can man intentionally create? And what order can he bring to things?
It's probably, book 1 is all centered around knowability.
Yeah.
It's focused not on the object, but how does the human mind know?
Exactly.
And what's the dimensions of knowability? First degree, second degree, etc.
Exactly. And then these, for him, the manifestation of that is these geometric forms.
The only question that brings up to me is if the issue really is how the human mind comes to generate, through a process of construction, these knowable divisions, starting from the circle, and then within that limited framework, you're able to produce these knowable divisions, and then it sort of seems to beg the question as to what other kinds of starting points can you begin with to come to realize through a similar kind of process of construction as you did with the circle, but maybe using something else as your starting point. What other kinds of proportions would be found to be knowable, which you previously would have thought to be unknowable? Something that popped into my head as we're thinking about this kind of reminds me of what Lynn was talking about in So You Wish in the third chapter on thermodynamics, and how this idea of the ontological transfinite, or the idea that you can conceive of higher principles or higher geometries, if you will, which your current principles or your current geometry is nothing really but a special case of. But once you discover that higher principle, you're enabled to come to know more things than you were able to before. And so, anyway, just things that are coming to my mind as we're thinking about this circle question and why that represents, and how starting from the circle and then using that to determine what's knowable, how it seems to beg the question that there's other principles, beyond that.
Yeah, and also look at what Kepler unleashed. I mean, he unleashed a whole era that we're still living in the unfolding of, really, of science, with making possible the idea of a physical ellipse. You look at what he unleashed in music with the process of tempering, which is an entirely new kind of process. So, yeah, it's a good point. It really is interesting to think about using a certain mental geometry, but then what you end up opening up for the noosphere, for mankind.
I would also ask the question of how connected this is to Cousé's work on the quadrature of the circle. Because prior to Cousé's discovery of a proof of the quadrature of the circle, it was not understood. The circle is a higher species.
Can you get a little closer to the microphone, Daniel? You're breaking up.
The quadrature of the circle proof from Cousé is that the circle is a higher species than the other geometrical figures involved, as opposed to what Archimedes had prior and had lasted for thousands of years, that the circle is just like a different species as opposed to a higher species. So I wonder how that plays into this.
Good point. Okay, I should probably get to wrapping it up here. Are there any last questions? Okay. Well, that's good for today. And we'll see y'all next week.
Sunday.
I'm sorry.
And Sunday.
We'll see you all also on Sunday at 8 p.m. for the overview.
Thank you.
Yep.
Okay, good.